Okay, come. Now the other thing. Watch out for conductors and insulators. Okay, so if this is a conductor, charges can move.
How are we supposed to go next page? My finger got broken. My finger broken. I cannot do it like that.
All right, so let's say if I don't do anything, if I don't do anything, eventually you will see this. Okay, they will distribute uniformly if you don't do anything. Okay, remember they can move through the whole conductor. So this is what will happen in the end. Okay, but on the other hand, if I put something here, okay, I put this near to this object, what will happen is all the positives will be drawn near this side. Okay, can. Okay, I also don't want to go into too much detail about this unless there's specific questions. Any questions about this? No? Okay. All right, Joey, this one is for you. These are the notes from last week. Come, guys, can you try this?
Red balance space. Oh, that's it. I got 11, Mr. George. Yeah. She told Mr. George. Oh, yeah, I did. What? Okay, that's what. For AM, like morning. My number, right? I just need to write it like this. Okay, I remove the dot, I remove the AM. Okay, I know how it is. Like 1,000. Very easy, right? For AM, 1,000 percent per hour. Yeah. You know me? Okay. Yes. So let's I give you. I have bugs. For the 2 years old. You know, she's not AM. You don't think it's funny. Can we stand and write down? Because just with the go up. Yeah. He has to stand and walk and go. And he doesn't like Miss Chu doesn't like me climbing on the table. Mr. George doesn't like me climbing on the table. There are also not allowing me. What? Miss doesn't let me crawl under the table. George doesn't let me crawl under the table. What? What? You don't like that one. George, this one? Oh my God. I don't know. Oh, I love this. Three. I don't think I like that. This is not my prominent name. Then just now what the first thing that I did here? I added what? You added the zero? Yeah. Zero? Right? You like to make something. Okay, very good human body. I don't think. And I. I'm my nuts. I'm my balls. I'm my nuts. Alright. I thought this was. I thought this was. It doesn't. How does it not? I thought it's not the least thing. It's not the. Right. It's alright. AM. But PM. No. No. Because and I'm going to word differently. My brain. Only the same right cell. It doesn't know. Wait, can you repeat the whole thing? Oh, yeah. Oh, I'm crossing. 4 p.m. Morning from 12 to all the way until. So for at night, I need to get hours. My work. I don't like that. Not like that. Not like that. Like that. Go. I finished this one. I need to finish ready. Then 4 p.m. is afternoon time, right? Yeah, I'm like. Wait, probably not. It's after. Yeah. And then at the time I'm sleep. Please, the one 12 p.m. 12 a.m. 0. What's 0? Bruh. You should have 0. I got it. If you cross, eventually just 0 hour 36. What's PM? But if I give you from 36 PM, then it's like how many hours? It's 4 hours. It's 4 hours. Okay. Let's see right. Let's see right. I can get this part. The first one. Get the first one. Look at the next PM. Oh, I went here. I need to add 12 hours. 12 plus 2. Wait. Okay, never mind. 12 plus 2. Oh. 1. 12 plus 2. 12. It's 12. 1, 2, 3, 4, 5. 14. Then you just write down the last 2 lines. Do you ever want the PM sign? Please. What PM anyway? What sign? What PM? What PM for everything? So PM is for the 2-hour clocks. But now we're looking at the 24-hour shift. Oh, I am. PM is for hours. It's been 5 minutes. If you're about 5 on 3 PM. to change to okay, change cost. Ah, this one, how to change to change cost? I'm not. Ini kalau kita update pada kan stage time what tapi ini juga kayak back to the topic. Yeah. I thought it grew up to automatic direct flow. Each building calls. Okay, good. Isn't by two, it must be yes, but I am afraid from like that focusing image. So you can do what? See, all these right? They reflexive, none of these. So you can try it. The first one, yeah, what is no. What is the equal? Bro. If you have the f as 12, no, the f you just look at the 0. But this one becomes like so for AM clock, right? 12:36 is the same as 0 hour. So you also you don't need to put 0 stat. So you just write. So then there's no one calculating. There's actually 0, 0, 1, 1. So this was 7, 11. 7, yeah, 7, 11, 11, go to divide some 8. No, so AM and what they do? Here actually. Then I go to other now because there are two projects. This must be fixed. Nice. Right. That's not I said I told you already that for AM clock, 12 hours patient is wrong. You start from this video. Then you go there. So this one you just focus. Okay, 12 AM is usually 0 hour. 12 PM is 0 hour. Let's say I do 9:1 AM. No, I thought you're right. For this one, if I change to 24-hour clock, right? I just get a 0 and I remove the dot at the end. It's not right. You just have your angry. For AM, so you just set at the numerator. Okay. I remove the dots and then so you do like this. That's not the bigger here. Oh, I do. Oh. Yeah. Ah. I think I read the long video.
Okay, this one, right? This negative charges here, right? Now, what else did they say? Copper also contains negative charges, but initially, the copper is neutral. Okay, it's neutral at first, but what happens then? Oh, by the way, what's the name of these negative charges in the copper? What are these negative charges? They are electrons. Can make sure you recognize that. Actually, the question gives you a lot of hints already. Imagine your plug is negative. So negative can attract positive. Negative can also push away negative. So in this case, which is which? It's pushing away, no? So basically, the electrons are going to go downwards. Right? So what you can say is electrons are repelled. Make sure you use all this scientific word by negative charges on the cloud. All right. And they can flow downwards into the plate. So try to use all these terms even in the question. Okay, so that's what the question asks, but I want you to think a bit further. So eventually what happens is this, even though you don't need this, you don't need to add this in your answer, eventually the top here is going to be positively charged. Yeah, because all the electrons have gone down. So therefore the top is positive, but no need to include your answer because that's not what the question is asking. But you should know that's what happens in the end. But the story hasn't ended in case you don't realize. It depends on your question. What's going to happen? Now, the question didn't ask, but I want you to think a bit further. What next? Negative? Positive? Wow, guess what? You are going to have a current discharge. Okay, once you have positive and negative, there's a potential for current to be discharged. And of course, in this case, this is called lightning. Okay, I mean, this is not asked by the question, but well, you should be able to figure this out as well. Okay. Why are they repelled? Okay, come. First thing first,
Giden. Y-O-N. And that's how you spell Gideon. Gideon. Oh, bro, lovely. Yeah, that's you. Yeah, that's you.
okay, neutral. Same number of charges, positive and negative, neutral. Now, if I put something here, negatively charged, what happens here? The negative, you attract the positive and push away the negative, right? So, correct? Still neutral, no? The whole thing is still neutral. Just that one side is positive, the other side is negative. Okay.
The positive charges will still be like
Yes, but for me, I mean, for your answer, you can write positive charges are attracted. But essentially, it's the electrons that are moving. Even though for physics, they don't focus too much on that. But that's not the end. Let's say if I add in a wire here. Yeah, what will happen? All this you just slow downwards. Okay, so all these negative charges will just slow downwards and it's no longer neutral. Provided there's a ground, there's a wire that goes into the ground. That will happen. Okay, then. So there's lightning eventually. But of course the question didn't ask for that. So you don't have to mention that. But you must know in your mind that lightning is possible. If there's no lightning, okay, what's the question again? If there's no lightning? Oh, if there's no lightning, then basically this will happen. Hold on, let me erase. Now, if there's no lightning, then this is what happened. The negative are still there. And the top point is still positive. If there's no lightning. But at some point, when you have more and more negative, more and more positive, the lightning will just go because of the increasing voltage between the potential difference between the 2 points, between the cloud and the copper. There's plus and minus. Yes. There's a plus and minus. Minus, minus, no. Plus, plus, no. This means for like any place or yes, actually same thing, no? If let's say I don't know whether you have gone to science center before. They have this ball that discharges electricity. So let's say if I can have if this guy has a lot of positive.
So what's the answer?
This guy is negative. If you have enough charges on this side now.
No. I do already.
Yeah, the lightning will still go through. But remember, it has to go through air. But air is a poor conductor of electricity, right? So the charges must be strong enough to go through air. Just on pure air, not out though. Pure air as in? Yeah. You mean normal air? Okay, if the charge is high enough, you have positive, negative, and very powerful charges. Yeah, like we just go past, go through. And of course, provided the distance is close enough.
Okay. Something. Oh, you go to 1442. You go to 1442. Next. 1442. Nice. You have to wear glasses. Yeah. Better. So this one,
This one is tricky. Joey, are you able to do this one? Oh, okay. Have you read through the question, Surendra? Yeah, Joey, what do you, how do you explain it?
plus equals to 14.
The negative charges get attracted positive charges in the metal rod.
Okay, this one is also quite tricky. Try to follow. Now, I guess you know that this is neutral, right? Okay, hold on. Okay, this one is neutral. Neutral. All right, but same thing, I have a negative object here. So what happens? The top part becomes positive. The bottom part, the electrons will move downwards, right? Then it moves downwards. But there's one important thing. There is an intersection here. So electrons will move to the right. They will also move to the left. Okay, that is the part you have to explain. Now, what happens next? What happens? This part is negative. This part is also negative. What happens to negative and negative? They repel. So that is why, right? That's why this metal foil will move or swing to the right, because the metal foil is movable. So that's how you should explain it. I mean, I can write if you want to. Basically, negative charges. Say again. You wrote what? They repel. You have to write a bit more, Shivendra. Yeah, even though you get the idea right. So negative charges.
I don't think. What is it? I don't even know. You're right.
On metal rod
No.
are repelled downwards
a.m. not arrive at school.
by negatively charged plastic. Okay, but that's not the end. They are now located
1 hour and 12 minutes earlier.
on both the metal foil and bottom of metal rod.
I don't know. Don't know.
The negatively metal foil
Must be final
is
answer.
now
How many to the negative form?
repelled
How many?
by the negatively charged metal rod.
And they put the mama as a number. You didn't know me. I just. Okay, just. No, I go on me. No, I sure. No, I go on me. Yeah, just try. No, I don't. That's all I go through so many times. I don't know what example.
Okay, here so I present step by step,
Oh.
which is the best way to get the marks for this question.
Okay, so 8 hours, now I got 8 hours, and minus 1 hour.
But of course, make sure you understand the top of the metal rod is still positively charged, even though you don't have to include that in the answer. Right, Joey, fine.
You got to make 14 minus 14 minus 14. Is the answer 2? 10 minus. Oh,
Okay, so take note, the metal rod overall is still neutral, just that there's a separation of charges.
Yeah. I am schooling in my ends.
Okay, Ken?
I go to the last question.
Have you done this one, Joey? Yes. Okay, look through it, Sirendra. Have you finished the rest, Joey? No. Okay, finish the rest first.
I'm talking this is house. 11:15. 11 bring bamboo. Arrive at tuition center at 1 p.m. How long did bring bamboo take to leave the tuition center? Actually, I don't even know what to say. I forgot what I was to say. Look at me. I tell you. How long did it take to reach the bathroom? Look. Rồi. Con ngày ngọ. Con vớt. Con vớt trivia. Ôi, không know it. I don't know. There is change. I haven't done time. Oh, you don't know that. Oh, you don't know that. That's not. I do for so many times recently. It's because we are talking about. I am.
Hmm?
No, it's not talking. Yeah.
Same charge. Because they are pushed away, right? Yeah, same charge. But is it positive or negative?
1, 2, 3. The balls.
Yeah. But you have to explain why positive. Hmm? Yeah. Let her finish first. This one should be quite easy.
Plus 1. Yeah, right? So 20 plus 1. 12 plus 1.
Uh-huh. Why? Negative charge. It's a negative charge, the point. So how do you draw the lines? It's quite standard, right? Yeah, that's all. That's all. Okay, that's all.
Okay. I we have 1 chair. We have 0 chairs. You don't have so many chairs. No. Building scale 1 floor.
Okay, let's look at this one.
People change the thing about.
But for this one, I think I need to explain something that you have to be careful of.
So 13 hours minus 11 hours, how many?
Okay, so this is
So it's about
same thing.
13 minus 11.
I have a rod.
Everything.
Okay, come. If my question is like that, they don't touch. The word touch is important. They don't touch. What will happen here? In your question, they touch. But let's say they don't touch. What will happen? Yeah, Joey, what will happen? Okay, you will have this happen. Okay, can Shivendra? But what else? What else? What else, Joey? What happens next if it's like that? Positive, negative. Yes.
Okay, so any
Attraction. All right. And let's say they're allowed to touch. If they're allowed to touch, what happens? This one quite complicated, huh? What happens when they're allowed to touch? Yeah, remember they're attracting, right? Attracting eventually, if they are allowed to touch, what happens? No, let's repeat something.
my mouse warning. No, the mouse They look like cameras.
Remember, both are conductors.
I like it.
Charges can move, right? So, how? What next? What charges move where? Okay, good. But don't forget, no, this metal ball itself is neutral at first. It's neutral. So, yes, it will partially neutralize the drop. So
Tomorrow. Yeah.
some of the charges will pass over. Or you can say partially neutralize the rod so that the ball becomes positive as well. Partially. What happens? At first, you have this number of charges. Some of them go here. But what next? It's not the end of the story yet, no? What happens next? You have positive and positive, huh? What they do? Yes. Positive charges cannot move, yes. It's the electrons that move, right? But electrons move from here to here. So now it's less positive. Whereas this one becomes positive. It's still the same story. It's the same story, or the same result. So essentially,
But they want to go a face review.
at first there's attraction.
They only want, these three teachers only wear one kind of mask.
And then you end up with repulsion. If they are free to move now, provided they are free to move.
They cannot respond. No.
Okay, good question. Can they become completely neutral? Think about that, no? The whole system, look at the whole system as a whole. At the beginning, if you take both as the whole system is positive, no? So can you get rid of the positive without anything from outside? No, you can't. So therefore, at the end, whole system is still positive. Alright, I started with 4, I end up with 4 as well. Unless you introduce something from outside. Okay, let's say electrons coming from outside, then yes, you can neutralize the whole system. But if the system is isolated, then you can't reduce the charges at all. Remember conservation of charges? You cannot just destroy the charges by on its own. Oh, anyway, for this, I've maybe spoken too much. Let's go back to this. All right, I hope what has happened. Essentially, this one becomes positive. Okay, so A is positive, because some of the charges go over. All right, so since A is positive, and notice there's repulsion between the two, you must also assume that it's positive. And how does this B become positive? Because rod Y positive too. And rod Y has passed some of the positive charges to the ball B. So that is how you deduce that rod Y is positively charged. But of course, Joey, you are totally right. At the end of the day, the particles that are moving are electrons. Okay? But of course, if due to the movement of these electrons, your positive charges in a sense are also moved from one point to another. But you're right, it's the electrons that actually move to create the positive charges. Shivendra, all right. Yeah. Joey, all right. But anyway, if you just look at the picture, it's obviously in this case it's a repulsion. Repulsion means they have like charges, just that whether it's positive or negative. Now, the last part should be quite straightforward. No, I think I've mentioned this already. Make sure you remember electric field. Okay, a region in which a charge object experiences an electric force. That is one. Next one, standard. Make sure you get it right. Okay, make sure the arrows are correct. It's always towards negative, so I don't think it's a problem. Make sure arrows are correct, so it shouldn't be a problem. Okay, okay. Now, go back to the MCQs. Oh, sorry, before MCQs, look at this one. Shivendra, what answer did you get? 1.2. Joey, you get that? 1.2. Huh? Actually, I can't remember the answer. Let's take a look. Okay. Yep. Just be careful of your units. All right. Ampere, time in seconds. Okay, number one, Shivendra, answer. D. Yep, you should get it right. You should. Number two, Joey. B. Okay, you should get B. You should. All right, try to get it right. Number three, a bit tricky, but still doable. Shivendra. B. Okay, good. Number four, Joey. D. D. D for dog. Or B for boy. Okay, make sure you get B for boy. That's the definition of the field lines, direction of the field lines. As I said, make sure it's a positive dash charge. Okay, positive charge. How will it move? Okay, if it moves to the right, that is the direction of your field lines. The field lines are also from left to right. Okay, Shivendra, just remember the point. All right, so it's a simple chapter, so try not to screw up on it. You should get 2 marks more or less for that. Okay. Any questions? No? No. Is this the what chapter? 2 chapter. Yeah. Okay. The difficult questions that will come up is application. If you have some funny thing, let's say for example, your ink. You know how does a printer work? How does a printer ink all these pages? Right, essentially. Look at laser printer. Now, for laser printer, the ink is not a liquid, it's a powder.
They go then when it's 7 minutes to reach space.
And essentially,
At what time did they reach school cover?
for powder is what?
I'm not. I think if I finish the paper, see, like going.
Alright, they charge the powder, the ink powder to become negative. How to charge? What are the ways to charge a powder or charge a solid? Joey, how to charge something? Yes, possible, but it's not a say efficient method. Basically, induction means a charged object. The charged object is brought close to your object of interest. Close, not touching, no touching. The other way,
I got really nice. No, I'm not right thing on the plot.
okay, the other way is by friction.
It's not, I know you.
Okay, that means your object is rubbed against something else,
That.
which is quite common. Correct, such that your object gain electrons to become negative. No. So
Scan my.
powder is negative now, negative. Then look at your page. If I have a piece of paper, and I want to print this number 1, what I do is I make this shape positive. I make that number 1 shape positively charged. Again, could be by friction, could be by induction, but normally by friction, because paper, remember, paper is not a conductor. And now your powder
Is always happening to me.
So now your powder stick to that page because of the attraction.
Because. This one is my game car. We put.
So just keep this idea in mind. All right. Opposite charges attract, but you must find a way to charge them first. One side is one item is negative, the other item is positive. Normally either by friction, which is for non-conductors, or induction for conductors. Right, but friction is common. Friction is quite common. Okay, so keep this application in mind. It can come out in some funny questions, not just this, but some other funny questions. The other one, the other example is
Write something.
okay, same thing. I mean, other things can be charged too. It can be a liquid. The liquid can be charged as well. But a liquid is typical. Depends on. It can be a non-conductor. Then you charge it by friction. All right. So that liquid is charged, and then you spray it onto the ground or the crops. And typically, the crops are opposite charge due to the nature of the geology there. So just be open-minded about these applications that they like to ask. It is a difficult question. Other than that, your questions will be just like that. No, nothing funny one. The funny ones will be something like this. That is the type. That the one that you have to think carefully. Normal printer. Okay, actually laser printer is a normal printer, but normal printer, let me try to recall. That one you need to check it out. I'm not so sure for inkjet, the liquid ink, I'm not so sure. Okay, because this is for powder, which for laser. Laser uses powder. Ink, I'm not too sure, but I suspect it's the same thing. They also charge the ink.
What do you use?
What do they use to?
What do you use?
Oh, what do I use? I use laser printer. Now it's so cheap and common. Okay, let me see. Anything else? Any questions from either of you?
Or airplane?
Oh, right. So this aeroplane.
Yes. Oh.
Right, they spray the pesticide on the crops. But you know, if you just spray like that, the pesticide is going to get dispersed, no? Easily dispersed by the wind. So now the ground tends to be positively charged due to the nature of the property of the ground tends to be positive. So the trick is charge of pesticides negative. All right, conducts by friction. And once they are negative, they will get drawn to the ground rather than get blown away. Not in Singapore, of course. Singapore has no agriculture. All right, but other countries, yeah, definitely. USA, Australia, they use aeroplanes to spray pesticides onto the crops, onto the ground.
Isn't it big for the government?
You know, private business also does it. They have aeroplanes. In Singapore, it's very hard to own an aeroplane, but other countries, yeah, it's not that bad.
But farmers can't do it.
No, this guy operates an aeroplane business, so he will rent his aeroplane to the farmers. So farmers will pay a fee. Usually, it doesn't belong to the farmer. And don't forget, in your example just now, What is the charge? What is the charge on the clouds? Positive or negative? Yeah, they tend to be negatively charged. All right, and sometimes they will induce the ground to become positive. Okay, obviously they're not touching. No way for the clouds to touch, right? And no way for them to be pulled together. So induction will occur. So there are quite a lot of things you have to think about. Are they free to move towards each other? Okay. Are they immobilized? If they're immobilized, then induction will occur. But don't forget, no,
Can you help us?
don't forget, the cloud can become more and more and more negatively charged due to the air passing across it. So therefore, it can also, this becomes more and more negatively charged. It also induces the ground with more and more positively charged. Remember, in this case, they can't move towards each other, right? Due to the way the air meteorology works, they can't move towards each other, so they can't be attracted to each other. So what happens next is, I think you know already. I mentioned it just now. Okay, the discharge will occur. So keep these concepts in mind. Is it possible for them to move together to neutralize each other? Can they come into contact? Right? Or if they can't come into contact, induction occurs, but you also to ask, will the charge keep on increasing? If the charges keep on increasing, then you have a bigger and bigger potential difference until the current will just go straight through the air. That's the extreme case. Sorry? But oh yeah, the cloud the different story already. Okay, any questions? Any questions, Joey? No? Shivendra? No? Okay, I think that's all for today. How do they prevent it? Wow, not easy.
Because it's here, it's already considered.
How do you prevent lightning?
So I bring it over, I'll make it 14-hour and sleep for it.
Normal building. What did they do? They have a lightning rod. The lightning rod will concentrate the charges here. So the lightning prefer to hit the concentrated charges. And of course, that avoid damage to your ground or to your building. That's one way. Okay. All right. If you look carefully, you can see the lightning rods on top of the building, the sharp. There's a sharp rod. In fact, many sharp rods. Okay, anything else? All right, so yeah, that's all.
No, I don't care.